So we're going to talk about parallel circuits now, and the biggest thing to remember about parallel circuits is that each component in a parallel circuit is on its own loop. So parallel basically means it's like a ladder, so each one is on a parallel loop on its own. So it determines different kinds of sharing here. Whereas before with series, you would have, one cake, right? And you'd have slices of your one cake that you would all have to share. Well, parallel is more like cupcakes, where each person gets their own cupcake. And so each person gets their own personal share of the item. All right, so we're going to draw these as well, so making sure that we know how to draw schematics of parallel as well as series. So for parallel, it says draw a parallel circuit connecting two resistors to a battery. So we have 1, 2 resistors, and then our power source. So we're going to start by, just like with series, I'm going to start with our box. Since we need 2 resistors on 2 separate circuits, I'm going to draw a line right in the middle right here. And so the idea now, I'm going to draw them out, is that we have one loop right here in red. And then we have a second independent complete loop here in green. Now notice there are parts of the circuit where both loops go through the same location, but there are 2 separate, completely separate loops. So we need to put 2 resistors on where each resistor is on its own loop, which means we need to find a spot where there's only red, and that would be right here. And we need to find a spot that is only green, which would be these 3 locations, but just for nice symmetry, we'll put it here. And then, of course, the battery, by just normal convention, will go on the left side. So first, our battery, this little line, big line, for the little nubby spot, and then the long flat side of our batteries. We have 1 resistor that is only on the red loop, and 1 resistor that is only on the green loop. So you can imagine that if for some reason something were to happen here, and that circuit were to be open, this green loop would still be intact, and so current would still flow in the green, but it would no longer flow in the red. So let's go ahead and put that back. There we go. All right, so now we need to label our items here. We've got the voltage of the battery, which is 9 volts. So we need our multimeter across the battery, and that is 9 volts. And then we have 2 resistors. One is 100 ohms, so across this resistor, we have 100 ohms. And then across this resistor, we measure 300 ohms. And there we go, complete drawing of a parallel circuit. So now let's draw another one. So we'll again start with our block. So our first major loop, and we have 2 light bulbs to a battery. So again, we only need 2 loops. So there we go. We have our red loop, again, right here. And we have our green loop, which is completely independent as well. So the battery goes between both loops, powers both of them. So we'll go ahead and draw in our battery, little line, big line. And then we have 2 bulbs. Each bulb is on its own separate loop, so we need a bulb at red and a bulb at green. So I'm going to use the heart one again. There we go. 1 light bulb, and then 2 light bulbs. So the first thing we need to do is label, looks like our ohms, so our resistances for our bulbs. So the red bulb across it has a resistance of 600 ohms. And our green bulb has a resistance of 500 ohms. There we go. The total current through the circuit is 0.005. So current has to be drawn in the loop, so it doesn't go around it like these do. It has to go in the loop. And since it's total, we have to pick a spot that has both red and green. So we could put it here, 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 or here. So I'll just put it in the bottom just because that's where I chose to do it. You can put it up here if you want, or over here. It doesn't matter, as long as both the red and green go through it. So let's draw in our multimeter. And our multimeter reading is 0.005 amps. There we go. So two light bulbs in parallel, each on their own separate loops, labeled their resistances, and through both the red and green loops, our total current is 0.005 amps. All right, so now we're going to draw and solve our schematics. So again, we're going to start with our box. This time we have 2 resistors and a light bulb, so a total of 3 loops. So we have 1 loop here. There's 2 loops and 3 loops. So let's color coordinate those so that we can see them individually. So we have red, we have green, and we'll have our third one as blue. There we go. All right, battery goes on the left side. So we'll go ahead and draw that in. Little line, big line. And then we have 2 resistors and a light bulb. So 1, 2 resistors, and a light bulb. Okay, 1 resistor goes on the red loop. 1 resistor goes on the green loop. And then our last item, which is the light bulb, goes on the blue loop. So each one of these is on its own separate loop. The voltage of the battery is 1.5 volts. So the first thing we're going to do is put in our multimeter. .5 volts. And the 2 resistors are 150 and 200 ohms. So we got 150 ohms and 200 ohms. The total current through the circuit is 0.02 amps. So total current means that all 3 loops have to go through that spot. So again, it's going to be here, here, or here. So let's put it here. So all 3 loops, red, green, and blue, go through this location. So this is 0.02 amps. Now we're going to solve these exactly the same way that we did with the series. So we're going to break it up into like the Sudoku things where we've got voltage, current, and resistance. So V1, V2, and now we have V3 and VT. Because we have 3 items plus the total. We have I1, I2, I3, and then IT. And then we have R1, R2, R3, and RT. So the first thing we can do is put in what we already know. So we know that the battery, so the total battery is 1.5 volts. We know the total current is 0.02 amps. And we know our 2 resistors. So R1 is 150 ohms, and R2 is 200 ohms. What we do know about parallel circuits, is that each loop pulls off the battery separately. So this is a cupcake, this is a cupcake, this is a cupcake. They each pull the same amount. So each one gets 1.5 volts. This is why batteries go dead so much faster whenever it's connected in parallel, because each loop is pulling the full voltage off of the battery. So now we can actually go ahead and solve for the total resistance, right? Because we have V and I for the total, so we can find the R. That'd be Ohm's law. V equals IR. So we have 1.5 equals 0.02 times RT. And so we're going to divide by 0.02. And so our RT is going to be 75 ohms. Now, if you remember from when we actually talked about parallel, the total resistance is going to be less than the 3 resistors, but close to them. So 75 is fairly close to 150 and 200. If we'd gotten some sort of decimal like 0.0 something, then something went wrong, because this should be relatively close to those others. So the next thing we can do is, hey, why don't we solve for the I's? That wouldn't be so bad, because we can still just use Ohm's law. So V equals IR, and so we have 1.5. 1.5 equals I times 150. And so if we divide by 150, then our I is going to be 0.01 amps. For the green one, we're going to have 1.5 again. Is going to be equal to I times 200 ohms. Now we should expect this to be lower because we have a higher resistance. Greater resistance, lower current. So if we divide by 200, this will give us 0.0075 amps. So notice the amps are different. The voltage is the same in parallel. The amps are different in parallel. Now, because each loop has its own current, these 3 will add up to the total. So 0.01 plus 0.0075 plus I3 should be 0.02. So what I'm going to do is just say 0.02 minus 0.01 minus 0.0075 should give us I3, because it's the total minus the other 2. And so for I3, we get 0.0025 amps. So this tells me, since this is the lowest current, this should be the highest resistance. So actually, let's trace over that with blue, 0.0025. So we're keeping up with our color scheme here. All right, so to find R, we have 1.5 equals 0.0025 times R. And so we're going to divide by 0.0025, and we get 600 ohms. Now what we can do is we can check this using that 1 over R. So here, let me scroll a little bit. And so we can use the 1 over R. So 1 over RT should equal 1 over 150 plus 1 over 200 plus 1 over 600. And if you plug all of this in, you'll get a decimal. So don't forget to inverse. So what you need to do is take the inverse of this side and the inverse of that side, and you'll get 75. So another way, again, another way to check yourself, make sure all of this works out. Check this way, check this way. Check rows and columns, and they should all equal out.